So the last thing to talk about in 11.1 is 3 types of potential energy. We talked yesterday about gravitational energy. There's 2 other kinds. So the second kind is elastic energy. So that'd be energy that's stored, anything that can bounce or snap or bend back and forth. So anything that involves bending or bouncing would fall under elastic energy. So I talked to you guys about a bow and arrow. So when you bend the bow backward, you give it energy. So if the string right here is not very tight, but now it is, you transfer energy from your arm into the string. At this point, it has more energy that it can give to the arrow to shoot it forward. That energy is stored in the bow until you release it, and is converted from potential energy to kinetic energy as the arrow goes forward. The third kind is mass. So mass itself contains energy within the bonds of the atoms. It is stored energy. And you can see that when you burn a substance or when you eat food, it breaks down. And those chemicals are then used to fuel your body. Einstein said you can use this equation to calculate the mass and the energy stored within matter, where E equals mc squared. Now the book gives this 0, it's also called naught at the bottom. Yeah. Let me just go to, so I'll just take that off there. Did you learn about naught in pre-calc at all? What that represents? It's just that 0 down there at the bottom.
I don't think so.
Okay. Well, it means ordinary conditions or standard conditions. So in this case, if you see E sub naught, it just stands for rest energy. It's energy that matter has at rest without moving. Does everybody have all of this down?
Not yet.
Okay. So Einstein said that you can transfer matter into energy, energy into matter. And so using this equation right here, what this says is that when you pull back a bow and give it energy, you've increased its mass. Now, the amount of mass you increase it by is so small you really can't measure it, but it is there according to this equation. When you release the bow, it loses mass as energy is transferred out of the bow. So I'll start here. So E sub naught stands for rest energy. And that's just energy that matter has on its own at rest. So that's all the notes for today. It's we just had to finish up 11.1. So I'm going to have you work on 9 through 13. It's on page 292. Did you have any questions about yesterday's homework or today's homework so far?
No.
Okay. So just work on 9 through 13 for today.
Miss Holly,
Yes.
are there any quizzes or tests coming up?
Next week I'll start with that. I haven't planned next week yet, but yeah, definitely count on having some kind of quiz or test next week. I'll let you know as soon as I have that planned out, but there'll be some kind of assessment for next week.
Okay, and it'll just be what you've gone over, right?
Yeah, exactly.
Okay,
Yeah. Mhm.
perfect. Thank you.
Miss Holly, so for number 9, when it's saying to draw a bar graph, how many bar graphs are you just saying like with the levels of energy for each thing involved in the
Right,
equation?
exactly. It's kind of like page 289. It'd be kind of similar to that.
Oh, okay. So how many things are we just going to do the spring and then the gun barrel?
Exactly, yes.
Okay.
Miss Holly, could you please go over number 13?
Sure. Okay, so
Okay.
the number 13, I'm going to write this out. The whiteboard back. No, that's strange. I lost my, here, hold on a second. Still learning how to use Zoom. Well, so I can't draw with my pen, but let me just read the question. So at 90-kilogram rock climber climbs 45 meters up to the top of the quarry, descends 85 meters from the top to the bottom. Initial height is the reference level. So he first climbs up 45 meters, and that's where he's at. I wonder why I can't. Let me go ahead and try to unshare this and go back to sharing and see if I can get my pen back, because I want to be able to write on here. Okay, let's see. There we go. Okay, good. Okay, so it helps draw it out. So we know he went up 45 meters. It's 45.0. And they say that this is really height 0. The reference level is at that point. So that's going to be our baseline height. And then he goes down 85 meters from the top to the bottom of the quarry. So now he's down here. And if the initial height is the reference level, find the potential energy of the system at the top and at the bottom. Draw bar graphs for both situations. So if the initial height is the reference level, oh, I'm sorry, actually, this would be the reference level. I misread that. And so it goes up 45. So let me go ahead and erase this part right here really fast. So we have to do two things. We have to first find this right here. So if he increases height by 45 meters, that's positive energy. So we would take his mass, 90 kilograms, and multiply it by the height. He went up 45 times 9.8. And then he goes down, right? And he goes down 85 meters. So that would be negative. Oh, wait a minute, sorry. This would be 45 above, 45 below, so it actually wouldn't be 85 there.
Oh, so it's still just 45 for the second equation.
Well, is that right? Let's see. So if he went up 45, now he's 85 above, then he goes from there to 0, and then that would be what, 40, right? From here to here?
Yeah.
So you would be going down negative 40. This is such a confusing problem. So it'd be negative 40 in here because he's gone down negative 40 from the baseline, which is 0 right here.
Yeah, okay, that makes sense.
Yeah, that's the confusing ones. Sorry about that.
No, yeah, I'm just glad that you were here to answer that because I would have had no clue.
But yeah, it helps to draw it out, and I don't know why they make it so complicated, but that's how you do it.
Okay, yeah, thank you.
You're welcome.
Miss Holly,
Yes.
for number 13, also when you're going down, would it be a negative 9.8 meters per second squared, or would it still be positive?
In both cases, just use positive 9.8. The only thing that you would make negative would be the height. And so,
Okay.
yeah, that's a good question. It'd be positive 9.8 in both cases. If you see G in the equation, it's going to be positive 9.8. So all that would change would just be the height being negative for the second part.
Okay, thank you.
You're welcome.
Miss Holly, for number 11, when it talks about the two different things that you're supposed to see how they change, for the rotational kinetic energy, was that the one that you were talking about that was, is it doubled or is it more than doubled?
No, it would be. It would be the velocity. If you increase the velocity by 2, you would increase energy by 4, if that's what you're asking. But if you double
increase the energy?
Yes, if you double the velocity, you double the energy by 4. Is that what the question? Yes, twice as fast. So that would be correct. What you would see for angular momentum, it would just be double. Because remember, it's the equation
Right.
L equals mvr. So that's just double for that. But for kinetic energy, the equation is 1/2 mv squared. So because velocity is squared, 2 squared is 4. So it'd be 4 times rotational kinetic energy, but 2 times momentum.
Okay, thank you.
You're welcome.